Good afternoon, I am Andrew Caruana and I shall now be presenting our paper titled An Analysis of the Relationship Between Words within the Voynich Manuscript, written by myself, Dr. Colin Layfield and Professor John Abela from the Department of Computer Information Systems at the University of Malta. The Voynich Manuscript is a medieval manuscript written in a language that so far has not been identified or successfully deciphered. The manuscript can be traced back to the 15th century and contains numerous illustrations of seemingly alien plants, zodiac signs, and astronomical depictions. Moreover, the language it's written in, known as Voynichese, is unique and has not been seen in any other work discovered thus far. The main aim of this work is to investigate and analyze word pair occurrences within the Voynich and other manuscripts, in order to determine if the patterns found in other works which are written in natural languages can also be found in the Voynich manuscript. This may help determine whether the manuscript is a hoax, a cipher, or a natural language, which are the three main hypotheses commonly considered by Voynich researchers. Now, there has been some previous work done on the Voynich manuscript to try and identify the nature of the text within. Some scholars, such as Schinner, support the hoax hypothesis and published an article in which he uses random walk mapping and token syllable repetition statistics to show evidence of this. However, on the other hand, some scholars such as Landini, who performed spectral analysis on the manuscript and other works, and Bax, who claim to have deciphered partial bits of the manuscript by comparing illustrations to their believed real-life counterparts. They both believe in the natural language hypothesis. Furthermore, there has been some work which has been done by Montemurro, which is similar to ours in that it involves co-occurrence graphs to determine a list of words with greater semantic meaning. The results of this also seem to indicate that the Voynich has some sort of linguistic structure. To explain the overall methodology, word pairs will be analyzed to determine if certain pairs appear more or less frequently than their inverse. If this is found to be the case in the natural language documents, the same analysis will be done on the Voynich manuscript, and if a similarity is observed, it might indicate that the Voynich has some sort of linguistic structure. This process, however, will be further explained in greater detail later on in this presentation. To start off, the works included in this paper include certain books from the King James Bible, specifically Genesis, Exodus, the Book of Job, the Gospel according to St. Matthew, and the Acts of the Apostles. These particular books were chosen in order to emulate the different sections within the Voynich, and in addition, Shakespeare's Julius Caesar and Macbeth are included along with Dante's Divina, Commedia, and the Voynich manuscript itself. Furthermore, all the books in the Bible, Macbeth and Julius Caesar, are in Old English and La Divina Commedia is in Old Italian. The first step after acquiring these datasets was to pre-process them. So punctuation and digits were removed and all text was converted to lowercase. Furthermore, stopwords were removed for all documents using a frequency analysis process. To expand a bit on how stopwords were removed, the most frequent words were calculated for each document and the top X% were removed. The value of X was not the same for each language, so for English it was 0.001% and for Italian it was 0.002%. These values were found to be the most balanced through manual experimentation. However, the same couldn't be done for the Voynich since its meaning is unknown and hence manual experimentation via meaning isn't possible. So the value of X for Voynichese was set to 0.0015 since it's the average of English and Italian. After the pre-processing was completed, word pair co-occurrence graphs were generated for each section of every document to serve as an underlying data structure and to allow the visualization of the word pairs and their frequencies. The graphs were generated using a sliding window technique to find and associate words with each other and form pairs. This means that a word pair may not necessarily contain words that are adjacent to each other in its actual document. An example of a co-occurrence graph can be seen on the slide below, where each node represents a word and each edge represents a word pair. The direction indicates the order of the pair and the weight represents the frequency of the pair in its given section. The term skewed pair is used to denote a word pair that appears much more frequently than its inverse. For example, let word pair P equal A, B, where A and B are words. Its inverse pair Q would then be B, A, as the inverse of a pair is comprised of the same words but in the opposite order. P would then be a skewed pair if it occurs much more frequently than Q in its document, and is greater than the predetermined frequency threshold. For this work, the threshold was set to 5 after experimenting with different values, as most documents other than the Bible did not have many skewed pairs with a large difference between the pair and its inverse. Hence, setting it to 5 proved to strike a good balance. To illustrate this concept with an example, however, take the pair brown dog. The word brown is much more likely to appear before the word dog rather than vice versa, at least in the English language. And since English has this property, it would be interesting to see if this is true in the Voynich manuscript itself. These are the 10 most frequent skewed pairs for each document. As can be seen for Old English and Old Italian, there are some key phrases that were picked up, such as maybe, good morrow, Holy Ghost, and Spirito Santo. For the Voynich manuscript, obviously we don't know what the text means, but some pairs contain very similar words, which is interesting to note. Onto the results. Taking the skewed pairs calculations mentioned in the previous slide, a graph was plotted with the ratio of the number of skewed pairs to the total number of pairs in each document. This was done for the normal documents and for 3 random shuffles of each document in order to take an average, which should shed some light as to how text without structure performs. This graph can be seen on the left, where each blue column represents the normal variant and each orange column represents the shuffled variant of each document. The ratio shown on the y-axis is better explained with an example, however, so take the Bible with its approximate score of 0.0175. This means that for every 10,000 pairs in the Bible, 175 of them will be skewed pairs. This graph proved to be quite interesting as there was, as expected, a significant difference between the ratios of normal text and their randomized variants in Old English and Old Italian. However, with the Voynich, the difference between variants was only slightly more than double. However, that being said, this difference between variants is still large enough to imply that there is some sort of linguistic structure within the manuscript. The results of the skewed pairs calculations led to the investigation of the ratio of unique words. This can be defined as the ratio of the number of words used in a document without repetition is to the total word count of said document. This utilized randomly selected text segments from each document to find a reason as to why certain books had so many skewed pairs and others had so few. These calculations were run multiple times and an average was taken to minimize bias. The average result was then plotted and can be seen on this slide. To give an example as to what the y-axis of this graph means, La Divina Commedia scored roughly 0.5. This means that roughly half the words in La Divina Commedia are unique. These results seem to indicate that there is a roughly inverse relation between the ratio of unique words and the ratio of skewed pairs, as the scoring order is fully reversed compared to the ratio of skewed pairs graph. The reason this may be the case is that if a language has fewer unique words in a document, the more likely that document contains more repeated words, hence it is more likely for them to form skewed pairs. As a final statistic, the number of connections each word has, meaning how many word pairs each word is in, was investigated for each document. The results showed an exponential decay in each and every instance, which is similar to Zipf's law of word frequencies. The word connections in the Voynich manuscript follow the same patterns as the natural languages, which may suggest that it is not a hoax. Interestingly enough, the number of connections for La Divina Commedia was much lower than the other documents and was much less smooth. This could tie into its low score in the skewed pairs ratio, as if it does not have many connections per word, it is less likely that skewed pairs would appear in the first place. These graphs, specifically for the Voynich manuscript and La Divina Commedia, may be seen on the left. On to limitations. While the aims of this work were successfully accomplished, there are a few limitations present still. The first major one being that the Voynich was only compared to 2 other natural languages. It is possible that the Voynich is a natural language but is completely unrelated to these 2, but it may have similarities to other languages. However, comparing the manuscript to many more languages would be rather complex and time-consuming, especially since languages with vastly different structures such as Japanese or Chinese would be very difficult to integrate into this work. Furthermore, it would be rather tedious to try this with every family of language due to the sheer quantity of them and the lack of available resources for languages such as Maltese. The second major limitation has to do with the stopword detection. Automatic stopword detection had to be done as a pre-made list of stopwords for the Voynich does not currently exist and is impossible to create based on the meaning alone, since no one knows what the text actually means. This work could be expanded upon by taking the same skewed pair and unique word calculations and adding a third category, ciphers. So to put it simply, the document could be ciphered using cryptography techniques known around the time of the Voynich's approximate creation, and the same techniques could be run to see how they compare to the other variants. This might be able to shed some light as to whether the Voynich is a cipher or not. And moreover, artificial or constructed languages such as programming languages and conlangs could be added to see how they perform with this metric. And lastly, one could conduct further experimentation with using alternate methods of stop word detection rather than just frequency. And on top of that, methods such as TF-IDF could also be applied to these texts to filter out words depending on their relevance to the document. The results obtained from this work seem to indicate that the Voynich manuscript is not a hoax and shows some presence of linguistic structure within the manuscript. However, this does not mean that the manuscript is a natural language, but it can only lend evidence to one hypothesis or another. So in conclusion, whilst the Voynich still remains shrouded in mystery, this work has helped produce some evidence against the hoax hypothesis, and one can only hope that somewhere down the line, this work is developed further in order to attempt to uncover more of the manuscript's hidden secrets. Thank you.